Okay, a quick one on the steel. So I'm going to jump from my concrete model to my steel model. So there's my steel model, and the steel model is fairly basic. All it has is my steel framing, both my columns and my beams. So these both columns and beams are being substituted for the actual concrete columns and beams. So I'm not going to be measuring anything else other than this, and then I'll be substituting in my cost plan for my concrete beams and columns. If I was to select, I guess, one of those items there, the beam, and I can look at it by showing the properties, or click down here, show properties. I can see that the beam is fairly straightforward. What kind of dimensions does it have in? It has a volume, which I don't really need. It has a length. It has elevations. It has bolt spacing. There's a lot of information in there. Scroll down, geometric positions, constraints, and the structural section geometry, which is quite useful, the width, the height. And it should have a weight in there as well. There's the nominal weight, 101, 200, and that should be the last item as such in the beam. And what I mean by that is it should be that 101, and it is thereabouts. So the beams is fairly straightforward. When you're measuring the length of the beam, you've got a length item there, but the most important one, the length you're going to take is the cut length. So that's there. So the lengths can be a little bit different than the cut length. Length is from center to center, column center to column center, and then the cut length is the actual length. So I'm not going to measure beams today. You can apply what you're going to learn from the columns to the beams, because the beams are a little bit easier to measure because you've got an item for length available to you. But in the columns, if you click columns, I'm just going to scroll back up here, got all those on show. I'm going to click columns. You'll notice that if you click one of these items, show the properties, you'll note that there is no length. So there's the height and there's the width, which is the sectional area. You got your volume, you got everything that's, I suppose, in the actual beams, but you don't have a height. And I think we had a similar issue in the concrete columns as well. So we're going to have to do a little bit of extrapolation. What we can use, if you're aware of this, if you've got two dimensions, I guess you've got a volume there. And if you scroll down, you've also got a sectional area. So I guess what you're missing from that calculation, if you've got a volume, you're working backwards here. If you've got a volume and you've got a sectional area, which I guess is the area on section there, thickness on surface section. So section area divided by volume will give you that remaining dimension, which is the length. So it's the thing that is missing out of the calculation. If you've got a volume and if you've got an area, it's what's one divided by the other will give you what's left. Hopefully that makes sense. So let's use that. So clicking on one of the columns, I'm going to click on the plus, and because I'm clicked on it, it comes up there, and I am going to just put columns in front of that so I know what it is. Give it a different color, and click add details. And the first thing I need to calculate is that length. Now I don't, as I said, I don't have a length object property, so I can't, as I might do in the beams, I can't leverage off that. So I'm just going to put in length here, and it's going to be classification, structure, meters. Now, as I said before, my formula is not going to be length because I don't have a length to map to. It's going to be the volume of the beam divided by its area. So one divided by the other will give me a resultant value, which will be my length. And that's exactly what I'm looking for. So I do have a volume, bin property. You can click it there, see what it is, 0.05 meter cubed. And I do have a section called section area. If you typed in there, you see it there, section area. So volume divided by area in terms of what they're mapped to will give me my length. So on to my additional output. And then I want fireproofing. And I am going to structure and meter squared. Okay, now I don't have an area fireproofing to get a map off here, but what I do have is I've got a nominal height. Sorry, that's the width. I've got, if I scroll up, where is it? Yeah, I've got a width of 30.74, so scroll in there. 30.74, I believe that's the dimension from, I can do a little measurement rule from there to there. So 30.7 or 307 millimeters, 30.74 centimeters. And then I guess the width, or sorry, the height will be the opposite dimension from there to there. So to get my surface perimeter of this, to get my fireproofing, it's 4 times this side, then the inside, and then the inside of the next. It was the opposite dimension, and then the outside of that. So 4 times the width, 2 times the height. And that is, I guess, the surface perimeter of that column multiplied by its length will give you your fireproofing. So I need to start putting in a little bit of a formula here. So width times 4 plus the height times 2. And then I'm going to put brackets around that, and it's going to be multiplied by the length. Now, I've calculated the length here. It's the area times the volume, so I'm going to copy it, or I can just type it in again. And that's going to be multiplied by, I'm going to paste it in there. So in this case, I'm going to put brackets around those two calculations. So this one is to be done first. That's why there are brackets around the overall calculation. And then I'm going to multiply that calculation by my length, which is essentially my volume area. Now, once I do that, it gives me the width to map to here. And I believe I do have a width object property. To see it, then I can click it. I might have to click more. There it is there. So it's mapped to that. And then the height also mapped to it. Okay, so I'm happy enough with that. It's a little bit long-winded, but the reason it is because I'm missing a length measurement here. And then I want to calculate my weight. So another additional output. Also substructure or structure. This time tons. So length by weight by length. Weight by length is fine, but the length, remember, is a kind of a bit of a extrapolation. So I'm going to copy that. So what I'm looking for first is my length. I'll put brackets around it to calculate it. And then I'll multiply it by my weight by length. Okay, and what is my weight by length? Now, a lot of the time, I'll have to type it in there. My weight by length is 118. So I could type 118, but let's see if there's an object property, and I believe there is, clicking on the dimension. Weight by length, there we go, nominal weight, 117.9, so I guess 118 kg per meter, well, whatever the F means there in between as well. So what was that? If I type in nominal, I get nominal weight, and now I've mapped it to that. So nominal weight multiplied by my length, which is an extrapolation of the volume times the area, or at least the cross-sectional area, which I've got mapped to there. So you can see that that's probably the trickiest one to do. You can copy that, I guess, when you're doing your beams as a duplicate, but make sure that you're mapping instead of volume divided by area in the beams here, it's going to be just cut length. So you'll type in length there, and then you'll map to your cut length. So give that a go. But ultimately, let's see if this works. I'm going to click Start Takeoff, and then I'm going to highlight all my items. There'll probably be the guts of nearly 300 or 400 here. Well, there you go, 322. I've got 1,263 meters length, total length. I've got fireproofing of 2,349 meters squared. I've got a weight of 149 tons. So I'll just click correct, and that's gone in there now. And hopefully that is my calculations for my columns. So go ahead, now that I've showed you an example how to measure steel. I've done it before anyway, I believe, in a tutorial, but you can apply that logic to your beams calculation.